You're listening to the CyberWire Network, powered by N2K.
Heading to this year's Black Hat USA, the N2K CyberWire team will be on site recording from our podcast studio in the Spectre Ops Kennel Club. If you're interested in joining us for a conversation or learning more about what we're recording throughout the week, visit sponsor.thecyberwire.com for more information. And make sure you stop by the studio and meet the N2K CyberWire team. We'll see you there. This episode is supported by Black Hat USA. If you follow the research, you know a lot of it breaks on Black Hat stages. Hundreds of peer-reviewed briefings, more than 100 hands-on trainings, and the largest business hall in Black Hat's history. 6 days to learn the skills you'll need tomorrow, August 1st to the 6th. Use code CyberWire for $200 off your briefings pass at blackhat.com. We'll see you in Vegas.
You can't protect everything all the time. That's just an impossibility. And cyber in space is similar to cyber, here on our networks on Earth. As soon as you build a better mousetrap, along comes a better mouse, and you've got to keep evolving. Okay, we know we're not going to be able to protect. We know a better mouse is going to come along at some point in time. So how do we quickly recover when something does occur? And so those are all the challenges you've got to build in up front in order to have these, resilient systems that are going to last, so that people's GPS systems work.
Welcome, I'm Maria Varmazes, and you're listening to T-Minus Space Cyber Briefing. In this show, we examine the evolution of cybersecurity in the global and orbital infrastructure that powers, protects, and connects our lives. Hello and happy 250th Independence Day weekend to our listeners in the United States and wherever you are. I hope you're having a good one. On today's show, I'm chatting with Aurea Space CEO Damien DePippa, and we're taking a look at how space systems have evolved over the decades from government-run, siloed, vendor-locked, exquisite programs to a commercial-driven ecosystem enabled by lower launch costs, where commercial applications now largely outweigh national security uses. That means we're looking at an increasingly fragmented ecosystem needing interoperability, and yep, lots of cybersecurity implications there. Let's dive in.
I'm Damien DePippa. I'm the CEO of Aurea. I personally have over 35 years experience in space systems, C5ISR, national security space. I started as an aerospace engineer back at the end of the Reagan administration and what they called the Star Wars days. So I was one of those young engineers sitting around a table, kind of looking at each other going, can we really make two things hit each other 3 kilometers per second in the endo and exo atmosphere? And so I was solving those problems, then moved into, space systems, C5ISR systems. I was a chief satellite architect for communication satellites, for the U.S. intelligence national security satellites, and then led large space and intelligence organizations for companies, like Northrop Grumman, Mantech, Perspecta. I was part of the management team that sold the company Perspecta to Peraton, and then I was the president in Peraton. And then since then, I've been working with private equity firms, putting, I'll say, mid-sized companies together, really to be agile and attack some of the more innovative problems here in the marketplace. And now I'm excited to be working with Enlightenment Capital for the past few years, where we've assembled, a number of companies together into a mid-sized company, really to attack the command and control and communications continuum for space and advanced missile systems and operations. So that's really at Aurea what we do. We are innovators and integrators of solutions across the command and control and communications continuum for advanced space and missile operations. And we're developing software and hardware from orbit all the way to the tactical edge.
That's awesome. Damien, thank you so much for joining me, and thank you for that fantastic intro. It is wonderful speaking to someone who has really seen the industry change. I cannot even begin to imagine what you have seen over the course of your career, and how things have just changed from those Reagan days to now in the space industry, just let alone in the last 10 years. But again, we're even further back than that. I'm wondering if you wouldn't mind indulging me a little bit in telling me a bit about that evolution that you've seen. I imagine both in hardware and in the software world, what kind of changes you've seen and where we've arrived.
Yes, it's actually amazing when you look back over the last 30 some years, particularly with space systems, satellite systems, how they've evolved. Back in the early years when I was started, that this was all government run. You wanted to work in the space industry, you were either as part of the government or you were a contractor supporting one of the major government programs,
Right.
whether with the Department of Defense with satellite or NASA working satellite or space systems. And that's where you were kind of entrenched. And those systems were very siloed. I know you wanted to talk about this a little bit, but they were, usually exquisite. They were usually built end to end by single providers or teams. Very much vendor locked from that perspective. And to see it evolve over the years now, particularly as launch costs have really gone down in order to get things to orbit, it has really opened up the commercial space ecosystem in a sense, and that has brought in a lot of providers able to build and launch space systems for use to where, quite frankly, the commercial applications for space today outweigh the national security and military applications for space. And that has really advanced technology in a way that, we could not imagine, 30 some years ago, where, various technologies that apply to systems here on Earth are also applicable to space. And you've got those companies now building a corporate marketplace for space systems. And that has really broken down a lot of these, previous silos, these vendor-locked those solutions that lacked an ability to connect with each other. And that's really where we come in from Aurea, and we fit the market and we fill a gap where there are numerous fragmented systems that can't interoperate with each other, can't communicate with each other. They can't be updated, and that all goes to the siloing. And we come in, and what we bring is that non-vendor locked, open architecture ability, applying commercial applications to this space ecosystem.
I'd love for you to tell me more about breaking down those silos, because you said it so well about the classic thinking of these space systems being exquisite, custom built, beginning to end, and of course many of these systems are still in existence, and there's a long life for a lot of these missions. But with the advent of and the mushrooming truly of the commercial sector, that's changing. But still, of course, these systems have to be interoperable, and I cannot even begin to imagine the fascinating technical and also process challenge that this all presents to be able to interoperate with all these different systems, some of which maybe are on the old paradigm, some of which are new. I mean, how on earth do you tackle such an incredible set of challenges with legacy systems and new systems that are operating on these different paradigms?
Yeah, we still have a need for some of the legacy exquisite systems that are in medium or high elliptical Earth orbit doing, specific missions, classified or highly sensitive. And so that requirement will always exist.
Truly, yeah.
What we're really seeing is the proliferation of, the low Earth orbit, medium Earth orbit systems, where commercial providers are able to enter the market space. And we're seeing things like, Amazon coming in with their new system, Starlink, other providers, mapping the Earth every day with numerous satellites out there. And that's really the biggest change I think that we have seen is really how the commercial market space has driven the use of space for application in the commercial areas that now the U.S. government wants to leverage, right? And so now as we're working more and more with, the U.S. military, the intelligence community, they are really asking us more, how can we leverage these advances in commercial technologies to our benefit? Because they're outpacing what is being done, within the government in some cases. And with that, we come along to really break down that communication, command and control fragmentation and tie these pieces together even with things like cloud technologies. I mean, we are working one program right now where, U.S. Space Force wants to be able to have access to commercial antennas to be able to do the command, control, and telemetry of their satellite systems through a secure cloud environment with their own mission operation centers. And we are providing kind of that connectivity for them to be able to do that so that, because their own resources for commanding and controlling the satellites are really at capacity and they need to expand outward. And that's really where we come into play on these things.
Yeah, that's a great example, and I'm wondering if you can dive a bit more also into the challenges and opportunities here. I'm thinking of the incredible complexity of the different systems that we're talking about, and I'm just wondering if you can just tell me a little bit more about this.
Sure. Some of the challenges deal with being able to design a system thinking forward, knowing that technologies are going to change. How do you design a system that, like for us, example, where we develop the software and the APIs, knowing that in the future we're going to have to modify that as the technology moves forward and evolves as well. And so we do want to design those systems with open architectures. For example, like we are doing for the joint antenna marketplace for the U.S. government, where we're reaching out to commercial antenna providers, knowing that the technologies for the antenna systems are going to change. But not only that, knowing that the government may want to access multiple cloud providers. So whether it be a Oracle or a Microsoft or a AWS as the cloud provider, to be able to have that architecture open, knowing that you're going to have to be able to swap in and out different components in the future as they evolve. That's probably one of the challenges we work with mostly in designing these systems and planning these going forward. The other one, like everybody else deals with, is the cyber side. We at Aurea, we really work hard to bake the cyber solution in from the beginning into what we're doing and not try and bolt it on afterwards, recognizing too that you can't protect everything all the time. That's just an impossibility. And cyber in space is similar to cyber, here on our networks on Earth. As soon as you build a better mousetrap, along comes a better mouse, and you've got to keep evolving in order to solve that. But more importantly, too, you've got to design your systems to be kind of three ways. Ubiquitous, so that you have fallbacks in your solution. If something happens, you got other satellites, other systems to be able to take that load. If something gets attacked, you've got to be resilient, hardened, where you realize the most important aspects of your system are, knowing that you can't protect everything. Well, what must I protect, more than everything else, to be sure we're able to do that. And third, to be able to recover. Okay, we know we're not going to be able to protect. We know a better mouse is going to come along at some point in time. So how do we quickly recover when something does occur? And so those are all the challenges you've got to build in up front in order to have these, resilient systems that are going to last the test of time, that you continue to build on, so that, people's GPS systems work. John Deere tractor is able to get their weather data in order to, do what they need to do for the farming industry, and, every other aspect of our lives, from, communication to travel, to just basic logistics, that is so codependent on the space industry today can still operate.
Let's take a quick break now. When we get back, reflections on the rapidly changing space market from Aurea Space CEO Damien DePippa after this.
This episode is brought to you by Accenture. When your advertising operations fall out of sync, everything else follows. Spotify and Accenture are working together to reinvent the rhythm of ad sales, using automation, analytics, and smarter workflows to simplify campaign delivery and access better data across the business. The result? Less time spent on operations, more time connecting brands with the moments and fandoms that matter most. Learn more at accenture.com/Spotify.
Are all batteries the same? That's like asking if all soccer players are the same. Take Messi, the most decorated player ever. Is there any other player who has achieved that? No, just him. Now take Duracell. Is there any other battery with power boost ingredients inside? No, just Duracell. Remember, goats only trust goats because they're built different, and Messi only trusts Duracell.
Welcome back. Here's more of my conversation with Aurea Space CEO Damien DePippa. Something that you mentioned earlier that I wanted to go back to was about the concept of agility. And that's something that I wanted to ask you about as well. Given the incredible market pressures right now, and certainly we've many signals from the U.S. government about the need for more space solutions, not just more resilience in the face of adversarial action, but more quickly developed and responding to potential threats. Stereotypically, one does not often think of the space industry as being necessarily agile, but that is changing. Can you speak a bit to how you all are able to respond to those changing market pressures at speed?
Yeah, absolutely. Look, they are definitely changing, and we embrace this. We at Aurea, we actually love this, because we are agile and we are innovators. But for example, some of the latest competitions we've been involved with and are currently involved with are very different at how the government is acquiring what they're looking for versus what how they might have asked for it 20 years ago. Now they're asking for kind of proof. They want us to come in with our tech team and provide an orals presentation to actually demonstrate we know what we're talking about, and then they'll typically down select 2 or 3 providers to actually build a prototype over a short period of time, so that you're actually demonstrating your ability to be agile and innovative in solving their solution, and they're asking for commercial application to be involved in what you're doing. And so that's a definite change with maybe how we've done business, particularly, with the U.S. government in the past. And so, from that perspective, we love that because we are agile in that sense. Now, we also have the added advantage that we develop products commercially. So we have some large space systems providers that are actually, licensing our products, utilizing our maintenance agreements, maybe purchasing a little non-recurring engineering from us to help integrate those systems together. And as a commercial provider of these product lines, we're constantly evolving them ourselves. We're constantly updating with, for the new operating systems, the new technologies. And so from that standpoint, we kind of maintain a leading edge of agility and innovation that our other government customers then benefit from, because we're already doing it in the commercial marketplace. And so we're really kind of ourselves excited about this because it does break down the old barriers of the very large classical, systems integrators having a lock in the market because they're the only ones that could do it because
Right.
the government required a complete end-to-end system. But now the government's willing to buy things in parts and piece them together because they want these open architectures. And we've carved out this whole C3 portion, the command, control, and communication side of it, where we're experts on. And also because we actually have real space operators that have worked in that environment and understand how it works as well.
Damien, I'm very curious. I always love asking CEOs. You all are thinking about the market and the larger, the macro, so much more. And I'm very curious if you had a crystal ball for the next 5-10 years for the space industry as you see it. What do you see happening in terms of opportunities?
Yeah, there's going to continue to be commercial opportunity in space, particularly on the communication side. We're continuing to see that. We're seeing, we're seeing more constellations go in that deal with various types of communication. I honestly think, if I'm looking at my crystal ball, everybody's got their iPhones today based on cellular networks. I think cellular networks are going to be, a thing of the past at some point. Everybody's going to have direct to satellite, with their own phones, from that standpoint. And then you'll have worldwide connectivity no matter where you are, in that sense. And then I see as we are actively making progress towards interplanetary type activities. Hey, okay, we've just circumnavigated the moon again, and we got the whole Artemis mission, and now we're talking about moon bases. And then, Elon Musk wants to go to Mars, and there's plans for Mars. So the communication side of that is always going to be a major thing that has to be worked on. The command, the control, the communication, the use of satellite systems, how they connect, how they operate. And so I think that market's going to be around for a very long time, both on the military and the government side, as well as commercially. And we're excited about that because we play on both those market areas.
That's fantastic. Well, Damien, I'm recognizing that we're coming up on time, but I always want to give my guest the last word. If there's anything that you want to leave our audience with, anything that I missed that you wanted to talk about, this is sort of the bingo free square in the middle. Anything at all, I will hand the floor to you.
Yeah, great. Look, like I said, we're innovators. I also like to tout maybe a little bit of what we're doing in modeling and simulation as well as training for our systems. Because like I said, we have the technologists that understand how to do command control and communications from a technology standpoint. We also have operators that actually work real world mission operations centers, commanding satellites and doing the communication side of this. And one of the innovative things that we've done is we've paired up our operators with modern day software developers, modern day game developers, UI UX developers, and we've created training systems for the next generation of space operators as well as space warfighters. So, for example, we got tools being utilized at what's called the National Space Defense Center, as well as at the U.S. Air Force Academy, that is teaching the next generation of space warfighters and space operators how to operate in a space environment, how to command your satellite systems, how to do the orbitology, how to manage the payloads, and then even how to do space warfare, force-on-force space warfare. And we do it in a very modern-day gaming type environment that this generation of space operators used to seeing, who grew up in a gaming world where you didn't need thick manuals to learn how to use a system. It came on intuitive. So that's kind of another area, we've branched out into with our command and control communications talent, along with our innovative software development and systems development. And it's really gaining a lot of traction as well. And we're excited about it. We demo it often at various symposiums we go to.
Oh, that's awesome. Well, Damien, thank you so much for telling me about that and also for sharing your expertise with me and the audience today. I learned a lot from you, and that's the best part of my job. Is that I get to learn from my guests. So thank you so much for joining me today. I appreciate it.
You bet. Take care.
And that's T-Minus Space Cyber Briefing, brought to you by N2K CyberWire. If you like what you heard today, you will also enjoy our newsletter, Signals and Space. You'll get research and notes pulled together by our producer, Ethan Cook, and me, along with this week's top space cyber news stories. Subscribe by visiting thecyberwire.com/newsletters. We'd love to know what you think of this podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing cybersecurity landscape. If you like our show, please share a rating and review in your podcast app. Please also fill out the survey in the show notes or send an email to space@n2k.com. We're proud that N2K CyberWire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K helps cybersecurity professionals grow, learn, and stay informed. As the nexus for discovery and connection, we bring you the people, the technology, and the ideas shaping the future of secure innovation. Learn how at n2k.com. Thank you for listening to T-Minus. I am your host, Maria Varmazes. The show is produced by Ethan Cook and Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben, with content strategy by Mayan Plout. Peter Kilpie is our publisher. See you next week.
T-Minus.
Hey, it's Ryan Reynolds here from Mint Mobile. Now, I was looking for fun ways to tell you that Mint's offer of unlimited premium wireless for $15 a month is back. So I thought it would be fun if we made $15 bills. But it turns out that's very illegal. So there goes my big idea for the commercial. Give it a try at mintmobile.com/switch.
Upfront payment of $45 for 3 months, $90 for 6 months, or $180 for 12-month plan required. $15 per month equivalent. Taxes and fees extra. Initial plan term only. Greater than 50 gigabytes may slow when network is busy. See terms.